from SkySQL. SkySQL is a company that does MySQL and MariaDB and Kona consulting. So if you have a problem with it or you have questions about it, much like Oracle, makes somebody like MySQL from support, that's SkySQL is a support organization. MariaDB is a MySQL
I'm going to talk about it here.
Yeah, it's a MySQL fork that's done by the Monty program. But without further ado, this is Max Mether of SkySQL.
All right. Thank you for the applause. So today we're going to talk about MariaDB. And yeah, if you have any questions, don't hesitate. It's a small group, so we can easily answer questions. And I'm Finnish, by the way, so I have an accent, if you didn't notice.
But you know what? You never had an accent until you came to this country.
Yeah. And actually, it's more of a French accent.
It's not. You don't have a Finnish accent. You have an American accent because you didn't have an accent until you came to this country.
All right. If you say so.
The Finns are devoid of humor. No.
This is starting well. So the topic is MariaDB, right? Not my accent. I'm completely lost. So what is MariaDB? So as Sherry said, it's a branch of MySQL. Branch meaning that it's backwards compatible with MySQL. So it's a drop-in replacement. If you're running MySQL, you can just stop it, install MariaDB, and it will run, well, in most cases. It should run. It's completely open source, meaning that there are no closed source modules, like for some other things like MySQL where there are closed source modules. All code is open, there's an open bugs database and so forth. So it's a completely open source project. It's kind of controlled by one company, but all the code is free on Launchpad, and a lot of the contributions come from outside the company. So it's different from MySQL. Go ahead.
It's GPL or? It's
GPL, yeah. I mean, it's based on MySQL, which is GPL, so they're pretty much bound by GPL. That's MariaDB in a nutshell. So let's have a brief history. Where does it come from? So you all know MySQL, right? Who uses MySQL here? Okay, who doesn't? Who has never used MySQL? No one. Oh, one. Oh, excellent. Well, I'm not going to talk about MySQL very much. So this is more like the difference between Maria and MySQL. But so MySQL, back in the days, it was created by one person. It was a one-man project back in the 80s. At first, it was created just for his own usage, so he used it to sell consulting to other companies as a software consultant. And then eventually, actually because the platform MySQL was created on, it was actually, they decided to stop developing the platform. So he had to move it to some other platform. So he decided to do it in open source and on C, because he wanted something that wouldn't change, so that's why he went to open source. So no one would say, okay, we're stopping with this platform. So in '95, the first version of MySQL, as we know it, was released. So open source based on C code and not, I can't even remember what it was written at first. Something like Pascal or something basic maybe. Something weird. And of course MySQL, the company was created at the same time, so in '95, perfect timing. We had the internet exploding, we had the LAMP stack, and MySQL as a company grew quite a bit, and eventually was acquired by Sun Microsystems in 2008. And it's still a pretty good stuff, yeah? Do you have a question? Yeah. So that's kind of the really, really brief history of MySQL. It was a one-man product. It became, 10 million people product, and then it was acquired by Sun, and so forth. And when MySQL, the company, was acquired by Sun, some people who were working at MySQL decided to move out because they weren't happy working for a big corporation. I mean, MySQL was at its largest 500 people. Right, the Sun was whatever 40,000 when the acquisition happened. So it was a big change, 500 to 40,000. So the creator himself, Monty, he left Sun. He created his own company called Monty Program, and he took many of the core developers with. Well, they came. I don't think he took them, but they volunteered to join him. So they created this company called Monty Program, and initially the idea was to work for Sun to develop MySQL as external consultants, just not be bound by the big corporation, not crap, but whatever, restrictions. However, not long after the foundation of Monty Program, Oracle acquired Sun, and Oracle has a different history in open source than Sun, so it kind of changed the focus on Monty Program, so they decided to, instead of working for Sun to create, initially they were supposed to create a storage engine for Sun. So instead they released MariaDB and decided to focus on creating a branch of MySQL. And the first MariaDB was released in February 2010. So that's kind of a very brief history about how it happened. And of course, Monty used the money he got to create Monty Program. So you can say Monty Program is a Sun-funded company. Right, so who's behind MariaDB? There's Monty Program, who started the whole project. But it's also heavily being done by the community. If you look at on Launchpad, if you look at the code, 64% of the captains, there are people who basically commit stuff to the code. 64% come from Monty Program, and 36 are from the outside. I mean, this might seem low for an open source project, but at MySQL, it was 0 from the outside. At MySQL-DB, there was no contributions. If you get contributions, you have to, sign your life away, and you have to make sure that there was no infringement on patents and whatnot. So MySQL, basically because MySQL had the dual licensing, so you had MySQL on GPL, but we also sold commercial versions. And those commercial versions included indemnification. So we had MySQL-DB had to be sure. First of all, MySQL-DB had to own the copyright to the source code, and secondly, they had to make sure that there was no infringement on anything else in the code, which made it really hard to take contributions from the community. And this is, of course, completely different because it's GPL, so no one cares about infringement and other things. Right. That was very briefly the background behind MariaDB. After this, I'm going to focus on features. So basically, the difference between MariaDB and MySQL. So I'm going to list features here, and all these features, at least at the time they were created, they existed only in MariaDB. Some of these are now being created as well in MySQL 5.6, but most of them are still MariaDB only. Right. So it's a technical presentation. Anyone who doesn't like technical stuff, now's the time to leave. Right. So the first thing they did is that they added storage engines that weren't part of MySQL. Again, kind of for the same reason, because MySQL was GPL and commercial, so in order to include certain storage engines, they had to be, source code had to be owned by MySQL and so forth. MariaDB, of course, being GPL, was not bound by this, so they could take third-party storage engines that were also GPL. So some of them are listed here, PBXT, which many at the time said was a promising project. It's pretty much dead now, but at the time it was very good. And some others, including ExtraDB. Who knows what ExtraDB is? A few guys. Who knows what InnoDB is? Alright, it's the same guys.
Funny how that works.
Yeah. So InnoDB is the main transactional storage engine in MySQL, which basically provides everything you want in a transactional engine, so ACID compliant storage engine. However, InnoDB was created, it was originally created as a one-man project as well by another Finnish guy called Heikki Turi, who was a professor in a Finnish university, and this was actually his thesis to create InnoDB, the storage engine. But eventually, it got the storage engine became part of MySQL and became the main transactional engine. However, because it was created in the beginning of the 90s, it was fairly badly optimized for multi-core usage, right? I mean, it wasn't optimized at all for multi-core usage. Which means that as soon as you started using lots of cores, you ran into issues, bottlenecks, and mutexes, which basically, I think the earliest problems started already at 4 cores. You started flatlining your throughput. And Google at the time were heavy MySQL users, so they had a team who was actively using MySQL and actively developing MySQL, and they figured out some of these problems and fixed them. And they released this, which was called the Google patch at the time. So they released a patch which fixed many of the mutex problems inside MariaDB. And again, the same reasons as before, MySQL-AD had the patch, but couldn't really include it into anything. And also, partly because of MySQL having really slow release cycles at the time, it took like 2 years between versions. And MySQL was really close to finishing one, so they couldn't introduce new code without breaking it. So everyone knew there was a problem with multi-core usage. You had to fix in front of you, but they couldn't put it in. And then some guys in the community created a patched version of InnoDB and called this ExtraDB. So basically, InnoDB was just ExtraDB was just InnoDB plus the Google patches. So basically, a version of InnoDB that runs better on multi-core usage. And you couldn't get this through MySQL. You had to get it through either MariaDB or Percona server at the time. Then eventually they added more features to ExtraDB, but in the beginning it was only this. So it was a good version. It was a good add-on. Another cool feature that was added was microsecond support. So in MySQL, traditionally, the granularity you have is seconds, which is fairly useless if you're running a website or something, because everything should be below a second, or most things anyway. But you couldn't get a finer granularity than seconds, and this is one thing they added in 5.1. So for the slow query log and for the process list, you see your connections or your execution times in microseconds. And this is now being added to MySQL 5.6, but before MySQL 5.6, no way to get this unless you use MariaDB. Does anyone know what the slow query log is? Okay, a few guys. So the slow query log is where you get all your queries that are slow, right? But if your granularity is seconds, it's hard to see what's actually slow and what's not. Another thing that was added was thread pool, and well, they added a thread pool in MariaDB 5.1. And later, with MySQL 5.5, Oracle came out with a closed source module that included a thread pool. So in case you were an Oracle customer, or in case you are, you can use this closed source thread pooling. Right? If you use the GPL version, you cannot get it. And well, this is all fine because MariaDB had it. The problem was that the Oracle version was better than the MariaDB version. So the guys at multi-program, they were pretty angry with themselves, so they had to re-engineer the whole thing. So in MariaDB 5.5, you have a new version of the thread pool, which actually is on par with the performance of the Oracle one. But they had it long before Oracle, so it's just a good display of how competition works. By Oracle having a better one, they had to fix their own as well. Then there's a lot of features in the MySQL optimizer. This is partly or mainly due to the fact that when multi-program was created, in MySQL there was an optimizer team who were, the only thing they ever did was code the optimizer, right? And the optimizer is a fairly important part of a database. When multi-program was created, there was 4 guys in the optimizer team, and 3 of them joined multi-program. And well, 2 months afterwards, the guy who was left at Oracle felt a bit lonely, so he also joined multi-program. So the whole optimizer basically switched to multi-program, which meant that, well, Oracle had no one working on the optimizer, and multi-program had 4 guys. So the end result is that MariaDB has a lot of optimizer features. And some of these are now being added to MySQL 5.6 as well, but not all of them. So one of the first ones they did was something called table elimination. And table elimination is a feature that's fairly useless in most cases, actually. But for certain specific cases, it's very good. It works if you have something called an anchor schema. Does anyone know what an anchor schema is? So an anchor schema is basically a table structure where you put pretty much no attributes in the table, but every attribute is its own table. That's kind of what we're showing here. We have actors, and then actors have attributes, but instead of putting the attributes in a table, each attribute gets its own table. And why would you do something like this? Well, it's for flexibility, so that when you want to add or drop attributes, you don't have to do an alter table, you just drop or add tables. Or you don't even have to do that, if you add attributes, you just add tables, and you don't have to care about the people that don't yet have values for these attributes. So it makes your schema very flexible. And, well, very few people will still use this, but it's often used by machine-generated SQL. So if you're using some kind of middle layer, who will actually create the SQL for you, so you don't actually do it yourself, you might have something like this in the background. It's fairly badly optimized, but you can't choose how it generates the SQL for you. Right. So this is the background for the table elimination. Now the problem is that in order to use an anchor schema, you would normally have a view which spans all of the tables you have to show this one table or these attributes for these properties for this table. And in this view, you will have left joins between the tables because you of course want to show also the actors who don't have certain properties. And the problem is that in the MySQL optimizer, if you have left joins, it means that every single table has to be part of the join algorithm. Which means that if you have a query where you're looking for one specific attribute, you will have to join all of these tables. Say you have all these 12 tables, even though you only need 2 of them, the actor table and the property table. And the MySQL optimizer is incapable of knowing this in advance. And this is basically what it does, table elimination. It removes tables from the join algorithm that are not needed to produce the end result. And it might seem very trivial, but adding tables in a join actually makes your query execution a lot slower. It doesn't when you have 3 tables, it doesn't when you have 4, but when you reach 10 tables or more, it has a huge impact on just the optimization process itself. So here's a feature where if you have machine-generated SQL, by installing MariaDB, suddenly some of your queries would just be a lot faster without doing anything. So that's a good feature. Right, and that was pretty much the main features in the first version of MariaDB. I mean, the main goal with the first version was just to get something out there, to have something that people can use. Then in the next version of MariaDB, so again, MySQL was still having fairly slow release cycles, and the MariaDB guys kept producing features. So what they did was that they just added new versions on top of the previous one. So after MariaDB 5.1, you have something called MariaDB 5.2, which is basically MariaDB 5.1 plus a bunch of features. So it's still based on MySQL 5.1. MySQL, as most of you know, goes 5.0, 5.1, 5.5, and there's nothing in between. And MariaDB had some stuff in between, as we will see. So MariaDB added pluggable authentication to MariaDB 5.2, which came with MySQL 5.5. But at the time, MySQL 5.5 didn't exist yet.
Question.
Yeah.
Back on the slide. So I'm looking at that, and I see the anchor table in the view.
Yeah.
The on clause is anchor table ID to the, I guess, beef table with the little the non-anchor tables.
Yeah.
And then the next line it does the anchor ID to the other. Is it smart? Is it like sometimes when you're doing like a long left join like that, you don't keep linking it back to the anchor table. You might put like the foreign key and name to the anchor table equal to. Is it smart enough to break for example, you might do join AC birth date on AC name dot AC anchor ID equals AC birth date AC ID. You know what I mean? If you're using the foreign key of the table before, which is actually the primary key of the anchor table, is it smart enough to figure that?
It doesn't make a difference.
Doesn't make a difference.
No. From the optimizer, it doesn't make a difference.
Okay.
It will know which keys are equivalent and which table they actually refer to.
Okay.
Already the normal one, you don't have to use this one first. Right. Any other questions about this? Alright, so one thing they added in 5.2 was pluggable authentication, so you don't have to use the MySQL authentication methods anymore, you can use something else. And they added a PAM plugin, which Oracle also added, but Oracle added this as closed source module. So, yeah, they also actually, well, it's open source of course, so you can patch your own MySQL with this. So that's one thing. And then the other thing which is actually very useful, I found, is user statistics. And this was again coded by, I think it was Facebook originally, who coded this patch. So in MySQL, you have a lot of statistics on stuff that goes on the server. But the problem is that all the statistics you have are for the whole server, right? So you can see how many specific queries you've done, but it's for the whole server for this time you've been viewing it. And you can see how many typical index views you've done, but only for the whole server, right? So you can try to optimize the server based on server stuff, but you cannot optimize like your own tables or see which user is doing what. You can only optimize the server, right? But with this patch, what they added is that you have statistics on the user level, on the table level, and on the index level, which makes it a lot easier to optimize specific indexes, specific tables. So for example, you see what the specific user has done, which types of queries has he done, and so forth. Same with an index table. So for example, if an index is never used, well, you'll see it in the statistic, it will have 0 on the usage. And with the table, you will see how many times the table has been accessed and by which, and what types of accesses. So very useful for the DBA to optimize your, I guess, indexes and usage scenarios with patterns. So that's again a thing you can turn on and off. It's not on by default, but you can turn it. Then they added something called virtual columns, and this is a feature that has been, well, at least when I was in MySQL, which was until the Sun acquisition, it was asked for all the time, and it was said it's very easy, but we can't be bothered to do it because it's too easy. So it's one of these features that are really easy to make, but because it's so easy, it's not prioritized, so it was never done. And that's virtual columns. So a virtual column is that you have, you create a column on your table, which is based on a functional value of other columns in the table. So whatever the function is, you might have concatenate something to reverse or whatever. And you can choose whether it's a persistent column or a virtual column. The difference being that virtual means that it's calculated on the fly, and persistent is actually stored in the table. And the main difference here is that when it's persistent, you can actually create an index on it. So with this, you actually have functional indexes, which doesn't exist in MySQL, but you create a virtual column and then an index on the virtual column, which becomes like a functional index. So for example, one typical use case that everyone always talks about is IP addresses or names, like server names, right? Because they go from more specific to least specific, like I don't know, mail.google.com, right? If you want to do an index search using names, you cannot use it because you have the wildcard in the beginning, right? You want to go look at all the machines in Google, you start with wildcard.google.com, you cannot use an index for that. Because index, you have to, well, the tree is based on the first letter and not the last. However, if you reverse the IP address, then you can of course, the name, you can of course use an index. So here's an example where you could do this. Previously we always told customers wanted to do this, well, you have to store the reverse value and then each time you access it you have to reverse it back and forth. Here you can do it automatically. So it's a fairly useful feature, yeah?
Have you ever kicked around the idea of just doing a function-based index, like Oracle was doing for It seems like a lot of steps to get to the use
A function-based index.
Yeah.
Well, I mean, the virtual column is, in itself is useful as well. So, I mean, it's a lot harder to do a functional index on something non-virtual. I mean, that's kind of the key here. That's why it has to be the virtual column has to be persistent for you to have an index. It becomes more complicated if you do it on something that's completely virtual. So, I'm sure there's a workload for it, but I don't know if and when it will be okay. Another feature is a Sphinx storage engine. Does anyone know what Sphinx is? Okay, quite a few. So Sphinx is a full text search, whatever you want to call it, engine, software, which is a lot better than MySQL has full text search, right? If you use MySQL tables, but it pretty much sucks. But if you use it for very basic stuff, it works. But if you want to do some serious, if you have a serious performance demands, the full text in MySQL is not good enough. So most of our customers use Sphinx. The main problem is that Sphinx is a different process, and you have to call Sphinx first to get the full text search result, and then call MySQL to get the actual row data. So what they've done in MariaDB is that they've, well, it's actually Sphinx who created a storage engine, but MariaDB includes this in the build, so that you can access the Sphinx process from within the MySQL server. So you can actually create one query where you join the result of both. So you don't have to do two calls anymore from your software, as a developer. It makes Sphinx access easier. And then they also added something called segmented MyISM key cache. Does anyone use MyISM tables? A few. Alright. So, I said that InnoDB had problems with multi-core usage. Well, the same actually goes for MyISM. The problems with MyISM were simpler because MyISM has no functionality. It's basically flat files, right? So there's not much to worry about. However, the main mutex was the key buffer. So there's a buffer in MyISM where all the indexes are buffered. And well, this has a mutex, which means that if you have a lot of concurrent access, it becomes a bottleneck. And that's what they did in MariaDB 5.2 is that they allowed you to segment the key cache into different segments. And then, of course, you will get less bottlenecks with this. And here's one benchmark they used, where they have the well, the yellow line is 32 segments, and the yellow line is 64 segments, and the red line is 32 segments. So you can see that when you start having a lot of concurrent usage for MySQL tables, it does make a difference. However, the difference between 32 and 64 is non-existent even when you have 128 threads. So basically 32 is enough. But you still see quite a difference if you look at the blue line, which is no segmentation at all. You get a lot of better throughput. So it's a good feature, but only if you use MyISM. And only if, of course, you have high concurrency in your environment. Right, that was MariaDB 5.2, and then the next version, MariaDB 5.3, is still built only on top of MySQL 5.1. So we have MySQL 5.1 plus MariaDB 5.1 plus MariaDB 5.2, and more features. And in MariaDB 5.3, they had, it was pretty much their flagship. At the time, it was their flagship release with a lot of new features, especially features related to kind of NoSQL. It's not NoSQL, but it has similar features. One of the things, the first thing they added was a handler socket interface. This is an interface that was created by a Japanese company, a gaming company, and they had problems with batch loading and batch inserting data into InnoDB. It was too slow, right? So they toyed with the idea of getting around the SQL interface. So in general, when you execute a query, if you really simplify it a lot, you have three parts. You have like the parser, optimizer, and then the storage engine. So their idea was, so if you have a large batch of inserts or updates or something like that, why don't we just skip the SQL part, so the parsing part, and just do some kind of native storage engine operations. And this is basically what Handler Socket does. It allows direct access to the MariaDB storage engine layer. So no parsing, no optimizing, and so forth. The problem is that you can only do very simple operations because you don't have an optimizer anymore, and so forth. So you can do create, replace, update, and delete, simple CRUD operations. And in general, it's only faster if you have a large set of batch operations. If you have like 5 batch operations, this is not going to be faster because the parsing part is such a small part of the query execution process. But if you have enough, it makes an impact. I mean, for them it was worth it. But we've had customers who have tested it who said, well, the performance gain is so small that it doesn't really make sense to use. Then another pretty cool feature is dynamic columns. And the idea with this is to kind of go beyond the SQL standard. So in SQL, of course, you have a column, it has a definition, and you can only put values according to this definition, right? You have a data type, and you cannot put anything else in there. And this is all good, but in some cases you want to have something that's a bit more flexible, a bit like we talked about the anchor schema. When you have different attributes that only match certain of your rows, it's a waste of space to use kind of store null values for all the other rows where you don't have anything for this attribute. So with dynamic columns, it gives you flexibility on which attribute to store in a column. So let's look at an example. So the idea here is that when you create a table, you define your column as a blob, meaning just a bunch of bytes, right? And then when you access the columns, you have these functions for doing specific things. So there's a function for creating values in the column, and there's a function for retrieving values in the column, and so forth. So the idea is that you have a predefined list of columns, or you have a predefined list of attributes that you put in this column. And at the moment, it can only be integers, so you have to have somewhere a table which kind of translates an integer to what the attribute means. And then you just put values in there. So for example, here in this example, it's supposed to be some kind of web store. We sell stuff, right? The problem is that depending on what we sell, we will have different attributes. So for example, we have shirts, and they will have a shirt size. We sell mobile phones. Well, they won't have a search size in mobile phones, so they won't have that attribute, and so forth. And we have a PC which won't have that attribute either. So based on what you put in each row, you decide which attributes apply to that row. So for example, the shirt has attribute 1, which is color, and attribute 10, which is shirt size. Obviously, normally you would have more attributes than just these two. And same for the ThinkPad here, we have attribute 1, which is color. Pretty much every object will have that attribute. And then 3, which is operating system, which of course the shirts won't have because they're not operating system. Yeah.
If it's an integer, why are you using like an enum for that?
You mean, well, that's an enum. Oh, I mean to translate.
Is supposed to have a number and then having a
well, that's how it was designed. They actually are working on fixing this for the next version. So at the moment you can only use numbers, but they're planning on fixing this so you can actually use names. So in your column create, you'll be able to use a name instead of a number. But then of course you have to use the same name when you retrieve the value of the column as well. But yeah, internally it's just a bit. For each thing you store is a bitmap showing, okay, this is attribute that.
How is it just pulling out the integer for? Oh, is it key value?
Exactly. It's like not like a key value, but like a document store where each row you can have a set of attributes and you just say the key for this attribute and the value.
So what that's column lists. So like for column create on there, 1 would be blue, 10 would be extra large, right? And I get it. So, and there's, I guess, a way to get the exact opposite, the column values back instead of the...
It's on the next slide, yeah.
Looks like almost a hybrid with the set and the because you're using the set aspect of it to select which attribute you want to deal with, and then each attribute has its own enumeration.
Well, it's more flexible because you can put anything in there. You don't have to. You don't have to predefine the values. Like in a set or an enum, you have to predefine the values.
Right.
Here you can put anything, which of course.
Will it get unhappy if you did column create two? Some say one blue and then one black, so it's not really key value.
Yeah, it wouldn't like that. You would get an error if you try to put the same.
No. I mean, well, so one corresponds to what color it is, and then that's the value, which is independent of one.
Yeah, blue.
So one doesn't apply. One implies color. Then the value of color is blue.
Yeah.
Got it.
So it's
the one is which
two-dimensional as opposed to a single dimensional.
The one is which attribute you're getting a value to.
I was thinking about it kind of like a lookup table, like where you would have one blue, two black.
In theory, you would have a lookup table somewhere where one says color and 10 says shirt size.
Yeah.
To get it but I mean, normally you don't, because that's kind of the idea with the column store. The column store is that you don't have lookup tables. Yeah.
Do you know the backstory behind this feature? By chance, like why?
It was a customer request.
So it was like a real use case that kind of broke.
Yeah, it was. Not exactly this, but basically something like this.
And the key, the first part of the pair has to be an integer.
Yes. So the way to access the column has to be by integer. At the moment.
Right.
So the plan to fix the next time you could actually just put a name there.
Does it feel like is this about saving a join?
It's about saving a join. It's also giving flexibility, right? So
but the second table.
Yeah, it's about being NoSQL.
Yeah. There you go.
That's part of what it is. Part of it is the marketing aspect of it, that's NoSQL, but the idea is that it's flexibility. That's why people like about NoSQL. It's you don't have to predefine, you don't have to think about now every single object you're going to sell. Because you don't have to create a table with all the columns predefined.
But
you just say, okay, this is the attributes, and depending on what we end up selling, we'll see what gets into that column. That's kind of the idea.
But Postgre has a similar type thing, where you can have kind of like, it's not the same setup here, but it's a similar functionality in terms of the program. So like you can have a column, you can have a row that has effectively this. I think the Postgre one looks a little bit plainer. So it's probably, my guess would be that they went from Postgre to something similar to that.
Many databases have arrays, so you can put an array of stuff.
Right.
But this is more flexible than an array. But similar, the idea is similar. Because again, you can put any number of values for each row. So one row could have 15, one could have 3, one could have 14, attributes as well. So it's extremely flexible. Of course you pay the penalty as well, you cannot index specific attributes, but...
Yeah, that's the piece here where I'm getting a little lost, is that I would think from a performance perspective, like if I want to query, show me all the extra large t-shirts, kind of on my own, right?
Yeah, it would be slower, but it's the same. A lot of people use NoSQL and you don't have indexing.
Right. But when was the last time you could actually go to a website and say, I'm the size extra large, show me what's available to me? That would be a wonderful thing, but nobody does that. Because you don't really care if it's not in the size you want. You don't want to see all the stuff you can't buy. Anyone who wants to design a t-shirt site, by the way, that's free. So that idea, I don't need it. Credit, I don't need it. Money, just make that happen.
Actually, you can do that with Redless.
With what?
Redless.com.
With Redless? I would expect nothing less from Redless, which is the most awesome t-shirt site.
Alright, so if you look at that, how do you get stuff? Basically you do the reverse. There's a column get function. You say which column, so number 1 here, the number 1 column. And then you say, okay, I want to look at everything that's black, which we looked at here. So we get every object that's black and so forth. And you can also get the values, and basically like any type of SQL.
But not indexed.
But it's not indexed full text. Again, NoSQL, you do full text searches. You do full table scans all the time. It's flexibility over performance. That's kind of choice you make.
One of the use models is for tagging users who are online. So if you say, show me all the users that logged in last week, that'd be an index. That's near me, that's another index.
Yeah.
And then once you get that small a pool, then you start running through that also like computers or also like cooking or whatever. And then the idea is that those tags have already gotten to a smaller data set. Those tags are relatively easy.
Not going to be your
You're not going to be plowing through 100.
Exactly. You don't do everything.
Can you have multiple? So like you have one as color. Can you have two colors and one?
You can do whatever you want.
Okay, so you could potentially have more than one.
Yeah.
Of the same.
I mean, you define.
index.
I mean, the attributes are defined, hopefully in a document, but in your head. I mean.
No, I'm just saying. Like, can you say it's black and it's blue, like the same?
Yeah, as long as you just here, you have to say, okay, you want attribute 1 to be black, attribute 2 to be blue, and then if you want, you're fine the other way around. You say or.
No, but you're saying I want attribute 1 equals black and attribute 1 equals black. Blue.
No.
Sorry.
No, you can't have twice the same attribute.
Okay.
different.
Sort of like.
So then it's a little bit more
That doesn't map to anything in your life. Because you had something that was like black with blue polka
I couldn't
dots.
make my mind up. And I really
But then you provide two products.
Well,
That's four.
The base color and the polka dot color.
And do it right.
I mean, you can have a primary color, secondary color, for example.
right.
Right.
Nine of these.
Bottom erasing stuff.
Again, the idea is give more flexibility, less structure. A bit like the anchor schema. I mean, it's the same idea, but this is completely different in implementation. But the idea is to just have more flexibility, not to have to decide when you create your table, this is what I'm going to sell, this is the attributes, and then 5 years later you're like, oh no, we want to introduce this, but now our table is 17 gigs. It's going to take 2 months of alter table to be able to add these two columns.
Once you've loaded all this up, you got the billions and rows of information, and the person who's coming in right now and there's all the numbers and keys, is there any way to get, without having to read the entire table and aggregate it, is there any way to get like what the possible options are? Is there a very high
You have to read the whole table. You can read just a part of the table.
because they're all blobs and they need to be decoded.
You don't have to read the whole table. You can do a limit, read the first 1,000 rows and show me what's in there, and then you probably get a good idea. But I mean, if you use something like this, hopefully it's documented somewhere. Which often is not the case. I mean, I was at the customer when a while ago when they had lots of tables. I was like, how do you have so many tables? Are you sure everything is used? They're like, no, we don't. We have no idea if they're used. I was like, don't you have documentation? They're like, no, we don't.
That's what the statistics are.
So I was like, well, how do you manage? So, well, sometimes if we think that a table is not used, we rename it, and if no one complains, I mean, it's like a different, it's different development model. You let everyone do whatever they want, and then you leave it. This is kind of that development model. But of course, if you have user statistics, that problem will go away. You see which tables are not used. But they weren't on MariaDB yet. Those. So dynamic column is a cool feature, but it's also dangerous in a sense. Then they added all of replication enhancements. The main one is the first one. So you guys know about replication, right? Everyone knows about the binary log. Who knows about the binary log? So the binary log is the log where you store changes to the data. So it's used for replication, but it's also used for backups because it's like a redo log. Everything that changes data is stored into the binary log. So if you take a backup of your system, when you restore, if you have to restore, you can restore your backup, and then you have the binary log, and you can restore everything that happened after the backup as well. So you can replay everything that happened after your backup from the binary log. And the binary log has two formats. One is statement-based, which means that if I do an update, I will have an update written into the binary log. Right? If I do an insert, the insert will be in my binary log. So it's like SQL statements. You can just take them and issue the same statements elsewhere, and it will create the same data. The problem with this format is that many functions are non-deterministic, meaning that if I run one function here and now, and then someone else runs it 24 hours later, the result will not be the same. Which means that you cannot use it for restoring from backups because the data will not be the same if you run it 2 days later. Yeah, so that's why MySQL introduced a lot of weird things into the binary log to go past these limitations. But the fact of the matter is that some functions are non-deterministic and you can't get around it. They will not produce the same result if you issue them again. And that's why MySQL introduced something called row-based binary log. So instead of storing the statement, we store row images. So an image of the row before the statement and an image of the row after the statement. So this row that looks like this should now look like this. So it's very much secure because we don't care anymore of why the row looks like this, we just care about the result. So here you can use any function and your restore will produce the same result as it did when you set condition. So it's much more secure. I mean, well, initially it had bugs, of course, but now it was introduced in 5.1, so like 4 or 5 years ago. Now it's stable. But okay, so the problem with this is that the binary log was used for recovery purposes, and let's say you have a user who, by mistake, deletes a few rows or drops a few tables, and he's like, "Oh yeah, that table was useful. Can you restore it for me?" Now the problem with statement-based binary log is that the row-based binary log is that you don't have statements anymore. So what you want to do is you want to run the binary log up to the statement that shouldn't have been executed, then skip it and run the rest. The problem is that with the row-based, there are no statements, so it's really difficult to find that statement. And you can do it, but you can get the row which is kind of a pseudocode, so you see what type of operation and stuff, but you don't get the exact statements, which made it harder for DBAs to use this. And this is why they in MariaDB they actually include the original statement with the row images, so you can actually search through the binary log and find a specific statement, so you can execute everything before and everything after. So it's a DBA feature. So
it acts as a bookmark, basically, but it's not really operated upon. It's the row-based stuff that's operated.
Exactly, it's as a comment. So basically, when you use the row-based binary log, all the statements will be ignored, but you can search through the binary log to find statements. So it's used for DBAs, but it doesn't change anything for actually running the running of the MySQL. It makes the binary log a bit bigger because you have the statements there. It's optional, you don't have to turn this on. But a lot of DBAs asked for this feature. We had many customers who said they refused to switch to row-based binary logging because they lose the statement information. And that's why this was added. And some other verification features which are less useful. And then another feature, which is basically my favorite feature of all in 5.3, is a progress report for alter table. You know, MySQL alter table is done in the least optimal way, right? So in MySQL, if you do an alter table, it's like, alter table, let's lock everything. And then let's create a new table. And then we copy all the old data to the new table. And then when we're done, we release the locks and switch the tables. And this makes sense if you modify a specific column right in the middle. It doesn't make sense if you add a column or if you add an index, but it's still done like this in MySQL. So no matter what alter table you do, the table is locked during the whole process. And that's bad enough, but it's even worse is that you have no idea how long it's going to take. So you start your alter table, and you sit there, and you're like, okay, my table is locked now. And you sit there, and it's like, oh, it's been 10 minutes. My table is locked, no one can use it. And it's like you have web traffic and stuff. So you're like, okay, should you cancel? But then you're like, well, what if it lasts 11 and you're at 10? You're so close. You're gonna have to do it again later, right? So you don't cancel it, you wait. And then 20 minutes later, you're like, okay, it's been half an hour, I have to cancel it. It's like people are screaming at you, the phone going, what's wrong with our traffic? Well, this alter table, but I don't know if it's gonna last 35 or 3 hours. So you don't know whether to cancel or not. Well, with this feature, you do. Right. So you get a progress report. You start alter table, and if you do it from the command line client, you actually get a progress report in the command line client. But you also get it with the process list. So in the process list, you have a progress column which tells you how far it's gone.
Can you explain why the command line prompt is so weird?
Why the command line?
Usually the command line prompt says MySQL and it says like MariaDB and then bracket employees. What does that mean?
Always change.
What do you mean? You can change the prompt.
Yeah.
Did you change the prompt or is that what
Yes.
MariaDB usually
I
does?
no, MariaDB says MySQL. I changed it.
I think it's different in MariaDB 5.5. In MariaDB 5.5 it says MariaDB and then it's the name of the database
This
service.
is from 5.3 actually.
But in 5.5 that's
Oh, they changed it to 5.5? I should have known. I have used 5.5. I actually normally change MariaDB prompts because I run often multiple, so I haven't changed them all the time.
If you just do a regular show process list, will it be the same?
No, it's only in the information scheme on the process list. And I mean, this information is available. If you use any other client than the command line, this information is available. But of course, most clients don't handle this, so it's not shown for you. So if you use any other client, you won't see it from the client. You have to go to the process list. But if you use MariaDB client, you actually see it from the client as well. But so again, this is cool. Again, one of these features people have been asking for forever, but it's been so easy that no one has cared to prioritize it.
Well, the client will refresh and that'll.
Yes, good refresh.
so you do it in your screen session.
Yeah. Come back.
So the cool thing is now you wait 5 minutes and you see, okay, how far are we? And okay, it's going to take 2 hours. I'm going to cancel, or it's going to take 6 hours. I'm going to go. Very useful DBAs. And again, customer request.
Max, before you go on that price screen, is it going to do the like multiple indexes? It's going to rebuild every index as well, right?
It's so alter table is still as bad as it was. It's just now you know.
Does it take it then into
I'm
account?
saying, are you going to get a stage for each index that's getting built? It says stage 1 of 2.
Yeah, so it gives you stages. I can't remember. It depends on what operation you're doing. But copy to temp table is normally the one that takes too long. It means that you are copying the stuff. That's the one that takes the longest. If you have a big
Only there
table.
were a more agile storage.
Huh?
If only there were a storage engine that were more agile.
There are quite a few actually. You won't be alone soon. You know the first one?
That's supposed to be the marketing guys.
Yeah, Lawrence, pull it up
An
right
email.
now. So protect. Well, that's what he's trying to say.
Let me take a picture and put it up.
Pound it. Only
Well, the first one was actually NDB, but okay. But yeah, so some storage engines actually allow you to do online operations. So Tokutech, for example, NDB and InnoDB will soon do some operations. Right. So then, another thing they added was, of course, they still had the whole optimizer team. So they had a lot of optimizer features that they have been working on for a while, and basically they just added a bunch of optimizer features. Now, I'm not going to go through all of these in detail because I don't think it makes sense, but the main ones, which is subquery optimization and join relations. So all of these are changes in the MySQL optimizer, and most of these are off by default. If you use MariaDB and download them, none of these features are being used. You have to explicitly turn them on.
So I have 2 questions. One,
Yes.
do you have to turn it explicitly on because there might be some downsides?
Yes.
Okay, and then number 2 is that the same reason why they have like 5.1, 5.2, and 5.3? Because why wouldn't everyone just be on 5.3 if it has everything previous?
Everyone should be on 5.3. So why do they have 5.1, 5.2, 5.3? The reason was just to get features out there earlier.
Oh, so it's
So you take a limited feature set, you code them, you finish it, you publish it, and then you move on to the next set of features. It was just to have a faster release cycle,
right.
not have the 2-year mastodontic release cycle MySQL had back in the days.
Right.
Where when it's like 6 months before the release, okay, we cannot take any more features because just testing all of them would take so long, and so have smaller releases more often instead. So the number 1 feature of the optimizer is subquery optimizations, right? So a long time ago, MySQL did not have subqueries, so you couldn't combine subqueries into one. You couldn't do subquery syntax.
It was only like 12 years ago. It wasn't that long. Was that?
No, it's 4.1. It was not even 12. It was like 5 years ago. It was 4.
2005 was when 5.0 came out.
Okay, so it must have been 2003 then. So yeah, 10 years ago, 9. It's getting there. So MySQL had no subqueries, and of course everyone was bashing MySQL. There's not even subqueries. So MySQL decided to let's have subqueries. So they added subqueries. You know, checkbox, we have subqueries, and then people, oh great, you have subqueries, should be used. It's like, oh god, no. It's like, the performance is abysmal. And that was the case. You know, the consultant used to come to a customer and like, should we, the first question was, okay, do you use subqueries? They have performance issues. First question, do you use subqueries? Yeah? Okay, well don't. Like, the first thing a consultant did was remove all subqueries, because the subquery algorithm was just assuming the worst case scenario and then we just do that. Which meant that they were never fast. Not even the ones that could have been fast, but I mean obviously the ones that were worst case, they performed as they would have, but all the subqueries that could have been faster, they still performed worst case. And that was 9 years ago, and no one ever did anything to fix this. Mainly because we told all our customers not to use them. So we didn't need to fix them. No one ever complained because no one was using them. But the problem is again with machine-generated queries, right? So you have a middle layer who creates the queries, and the middle layer normally does pretty much the same queries for all databases. So you would have a subquery just because that's what the machine-generated query does, and you cannot change it because you use the middle layer, and if you start changing it, you have to write all the SQL yourself. So that's why they introduced this feature. So it does a few things, the subquery optimization. Number one is that subqueries that can be rewritten to joins will actually be rewritten to joins by the optimizer. So previously, again, the consultant's first thing would be, okay, look at the subqueries. All of the subqueries that can be rewritten to joins should be rewritten to joins because joins are faster. Not anymore, because now the optimizer can rewrite them internally. So it's actually fairly cool if you do a subquery and you do an explain where you see the execution plan. It will actually look like a join execution plan now because the optimizer will change it to a join. And of course that you don't have in MySQL. And some other things like materialization for non-correlated inquiries. So when you have a query, internal query, it's called dependent subquery, that has to be executed each time when you that's basically used each time you run the outer query, you use the inner query. Previously, it's just re-executed each time, right? So if you have 4,000 rows in your outer table, you have to re-execute the inner query 4,000 times, even though it's the same exact result. Well, now it's not anymore because it actually materializes the results, saved it. And it also has a subquery cache for the subqueries. Previously, there's a query cache in MySQL. It only works for entire queries. Now there's one that actually works for the internal queries. So the main output for this is you can actually use subqueries where you couldn't before. I mean, you could, but performance was bad. That's a good thing. That's the number one enhancement. Then there are some join additions. MySQL traditionally only had nested loop joins, which is like 4 loops inside each other. So you take the first table, and then you create a for loop, and inside that you have a for loop for the next table, and so forth. And this is very good for most cases, but you cannot do anything in parallel, and it's not good for distributed systems because it means that you have to step back and forth for each row and so forth. So they added a few other join algorithms, and some of these are also in MySQL. This is used, for example, for MariaDB or MySQL cluster because it's a distributed storage. They need other join algorithms to be efficient. Well, I'm not going to dwell in on this. And then some other optimizations like the write tables and view and disk access optimizations. Some when you have really large tables, multi-range read optimization makes sense, but as Sherry asked, the problem is that the optimizer is still not smart enough to always make the right choices, so that's why you can turn these off. you cannot turn off the subquery optimization, but all the others can be turned on. I mean, they're off by default. You have to turn them on if you actually want to use them. And multi-event read optimization, for example, we have some really good results with certain types of queries where you can almost 100-fold, the performance increases 100-fold. But then there's also some cases where it actually decreases a bit because the optimizer used it when it shouldn't have. But with the subquery optimization, I haven't seen a single case where they've actually been slower. And again, you can have a query that takes 14 minutes and it takes 10 seconds. I mean, 0.10, so 100 milliseconds after this, which is crazy that it could be such a big difference. I mean, most of my examples of really bad subqueries are no longer bad. I use MariaDB. Right. Then, one of the main features with 5.5 is something called group commit. Who knows what the group commit feature is? So the idea of the group commit feature is to increase performance when your system is I/O bound. And kind of in order to understand the problem, you have to understand how InnoDB works internally. So in InnoDB, you have durable transactions, right? So you have transactions, and when you commit your transaction, it has to be durable, so something has to be written to disk. So in this case, the system crashes just after your transaction, this change is persistent on your disk. Now, in order to speed up the process, of course, you don't want to be writing and reading from disk all the time, so you have a buffer for your data pages. And when you write stuff, you write in the memory, right? You don't write to disk every time you write something. And when you commit, instead of flushing all your data pages to disk, you have a redo log buffer, which just contains the changes, and then you flush the redo log to disk instead of flushing the data pages. So when you do a complex transaction here, you might change hundreds of data pages all over the place. So writing those to disk would mean lots of random disk access. Instead, you have a redo log where the operations are in a, not compressed, but in a very concise format, and you write a redo log which is written like as in a circular fashion, so it's not random writes to disk. So this is fast, right? Writing a redo log to disk is fast. So when you commit, instead of writing the data pages to disk, you write the redo log to disk, right? And this is all fine, but in MySQL, there's another thing called the binary log. And when you commit to disk, not only do you have to commit your read log to disk, you also have to make sure that your binary log contains the statement, right? Otherwise, if it doesn't, then you recover from a crash. It means that your binary log is no longer useful if it doesn't contain all the statements that are also written here, right? So you have to make sure that these are synchronized, the redo logs and the binary log, so that if your system crashes and recovers, your binary log is consistent with what's on disk. And the problem with this is that the binary log is external from the storage engine and the read log is internal in the storage engine. So the way it was designed is pretty much so that you prepare the read log write, then you sync the binary log, and then you commit the read log write. So basically for each transaction, you kind of have to do 3 fsyncs on disk. And the problem with this is that if you have a lot of concurrent transactions, they have to sit and wait for the disk to be free. So it's done in sequence. Which means that if your system if you have high concurrency, your system will easily become I/O bound, and this is your bottleneck, waiting for the disk to be available. And what the group commit does is that it kind of externalizes the internal commit. So it's done by an external, I mean, it's still in MySQL, but it's outside the storage engine, and it allows to group together multiple transactions waiting to be committed. So as soon as you start having a queue for transactions who want to fsync to disk, instead of taking transactions one by one, they take everyone who's in the queue, and everyone who's in the queue does these steps together. So instead of having sequential read and write access, you do one for all. Does that make sense? So instead of doing multiple transactions one by one, we do as many as you have in the queue at once. So as soon, yeah.
So the log buffer and the buffer pool, for some reason I would use this one. But MySQL 5.5 or whatever gives you an option to do something similar to this, like push it to a buffer to turn random to sequential writes.
MySQL 5.5 has an internal, an internal group committee in the DB, but it doesn't include the binary logs. If you have your binary logs synced, the internal group commit doesn't work anymore.
Okay.
So that might be what you're referring to.
Yeah, so you can toggle it to instead of committing to disk to commit to your operating system's log buffer as well. Like
okay, that's a different feature. Yeah. It's flush transaction at commit or something. Yeah, but it allows you to define whether you want to flush your transaction to disk or not. But if you don't, it means that you can actually, if you have a crash, you lose transactions, commit transactions. So it's fairly. I wouldn't recommend anyone to do that. It means that you don't care about your data.
But it's fast.
But it's fast, yeah, that's true. Obviously, if you don't care about committing your data to disk, then this is not a problem. You
if you have a battery backed rate cache, it's probably not going to be a problem if you do that.
Well,
because
then
you do it every second as opposed to doing it every commit.
No, there's three options. One is to make sure it's flushed to disk, one is to make sure it's flushed to the cache, and one is to not care at all.
Correct. Oh, yeah, no, the not care at all, you shouldn't.
Not care at all means pretty much every second, and that's what you don't want to do, because if your system crashes, it's gone. But the cache option is fine if you have battery, but it can still be a bottleneck. But and still, as soon as you include the binary log, that doesn't differ. We still have to flush the binary log. So you can make this fast if you don't have a binary log. You don't care about the binary log being synced with what's on the disk. But then your binary log becomes useless, or it becomes useless if you have a crash, because you don't know anymore if the last transaction in binary log was actually executed on the disk or not. So if you want a secure system, this is only a problem if you're IO bound. You might not. If you're not IO bound, this is not a problem. Right? It depends on your traffic and where your bottleneck lies. But so if you have this problem, then the group commit makes huge improvements for concurrency. And here's a graph made by Facebook actually. So there's actually a funny story about that anecdote. So this is traditional MySQL, right? So you increase your concurrency, and up to a certain level it works fine, and then it doesn't increase anymore because your disk is IO bound, and it doesn't help adding more threads. It doesn't make a difference because your disk is working full speed. So Facebook had this problem, and they actually created a patch, and this is the result of their patch, and they compared it to the MariaDB patch, and the MariaDB patch was a lot better. The MariaDB feature was a lot better. So Facebook actually created a new one, version 2, which was somewhere here in the middle, and then they said, okay, we give up, MariaDB is better, and we'll just take the MariaDB. So Facebook actually uses the MariaDB group commit feature. They don't use MariaDB, but it's all open source, so you can just grab the feature and so if you Google Facebook group commit, you will actually see these graphs written by Mark Callahan. But so the difference you see here is fairly high, right? If you have 64 concurrent users, you're around 6,000 commits per second, or around 27,000 commits per second. So there's a huge difference. So it's a very, very useful feature. And this came with MariaDB 5.3, and again, if you're not IO bound, this does not make a difference. And it depends on how fast your disks are. Basically, the slower your disks are, the more you gain from this feature. Also. There was another. They actually had multiple benchmarks. This was fast. This one slow disk looked like this. It looked like exponential. It never came down. Basically, I thought no one would believe it, so I put this one instead. Right, and then that was MariaDB 5.3, which was still based on MySQL 5.1. And then in December 2010, MySQL 5.5 came out. And well, MariaDB had been doing all their features 5.1, 5.2, 5.3 on the side, and they were like, well, when MySQL 5.5 comes out, we just merge them together and do a MariaDB 5.5. And it turns out it wasn't that easy, actually. So they thought it would take a few weeks. They're actually, Monty and his team are known for being over-optimistic. And it ended up taking 8 months to merge the code. So that's why MariaDB 5.5 wasn't released until April 2012, because it took them 8 months to merge the code. But they finally did it, and MariaDB 5.5 was released. It's basically 5.3, MariaDB 5.3 features added to 5.5. They added like a few minor features, like the new pool, thread pool, because they had to, because they were beaten by Oracle, they had to recode it. And a few very minor features. But it took them 8 months, so it was pretty bad for them to be so far behind, but the good thing is that they learned their lesson. And they've already started merging 5.6, even though 5.6 is not out yet. So, if anyone wants to know the thread pool, the idea with the thread pool is that in MySQL by default, each connection in MySQL is its own thread. Right? So if you have 100 connections, you have 100 threads. And this can be non-optimal in certain cases. For example, if all of your threads are doing small operations all the time, this means that your CPU or your cores have to do context switching all the time, because you have different threads coming with different instructions, right? So you have to do context switching between them. And that's when a thread pool is useful. So instead of having the CPU do context switching, the MySQL server will pool your threads, will pool your connections into threads. So if you have 20 cores, you will have 20 threads, which means the CPU just gets a stream of operation, just does it. The CPU doesn't have to do context switching anymore. So it's a fairly limited use scenario, but it's still useful in certain cases.
MySQL without thread pool, you said each connection has a thread.
Yeah.
Thread creation. Once the connection's over, the thread disappears, and then so spawn.
MySQL has a thread cache, so it means that when you drop a thread, I mean, all the buffers are released, but the thread itself remains open. It's put in the cache, and then when the next connection comes, you take the thread from the cache. And you still have to recreate the buffers, but the thread itself is recreated.
How does it differentiate between a thread pool?
So the thread pool is completely different. So the thread pool, when I say thread, it's like internal MySQL. It's basically MySQL connection, right? And here the thread refers to what goes to the operating system or down to the CPU. So it will still look like, if you have 100 connections, it still looks like it's 100 thread in MySQL, but actually the CPU only gets 20. I mean, the cores only get 20 or whatever you have. So it's the MySQL server that basically does the context switching instead of it doesn't do context switching. It kind of pre-orders all the operations for the cores. So I mean, you have to have you have to have concurrent threads more than you have cores, and they have to be doing stuff all the time for it to make sense. So it's not enough to have like 100 connections that do stuff every once in a while. It has to be 100 connections doing small operations all the time. That's when you would see gain from a thread. And that's MariaDB 5.5. So most of the features were coded before, because just the merge operation, which ended up being quite a large operation.
Sorry, one question on that side. Can you explain what the skip replication is?
No, because I can't remember. I can't remember. It's so that you. I'm gonna lie if I say something. I think it has to do with you can choose which. No, I'm not gonna say that.
Is that dynamically settable?
Yeah, it's dynamic. You can dynamically choose what to replicate, but I can't remember actually. I mean, I wrote the slide, so I should know, but I can't remember. Sorry, I don't know when
That's no problem. I'll look it up.
Yeah. But it's like, if I remember correctly, I can just say what I think it was, but I can be wrong, so you better look it up.
Sorry, I'll look it up.
I can talk about the limit rows examined though, because I remember what that is.
What's that thing?
But, yeah, thank you. So you know MySQL has a limit command where you limit the output of your queries, right? So you do select star, and then there's a limit 10, you only see 10 rows. The problem with this is that if you have a large join, you have join multiple subquery or whatever, with limit, you only limit the output. So it can still take 14 minutes to create the output and then just see 10 rows. So what rows examine does is that it actually limits the the processing of the rows. Once you process 1,000 rows, it will stop. And if it doesn't have 10 rows, it will limit whatever it has. Or 0. I mean, it will display whatever it has, or it might say, couldn't get a result with this. So basically, it's a way to just limit the processing time, instead of just limiting the output. Again, it's not useful for production, but for DBA it might be useful. So that MariaDB 5.5, it's been GA since April. So now the question is, what's coming next? And as you probably know, there's MySQL 5.6. There's been lots of development GMRs, right, coming out with different features. And what MariaDB is doing is that again, they have features they want to come out with, and they don't want to be limited by the Oracle or the Oracle release or MySQL Oracle releases. So instead of waiting for 5.6 to be GA, they're going to produce an intermediate release that contains some of the features for MySQL 5.6 that MariaDB deems stable enough, and some of the new features coded by the MariaDB team. And currently it looks like this. Yeah.
Skip replication is in fact to skip certain things. So it's a session-based variable to say log to the binary log, but don't replicate it. So you know how you have like replicating your DB or replicating your table? It's like that, but only for the session.
So it still goes to the binary log, but it doesn't replicate it.
Right,
It's different than setting SQL log bit at 0. Where
exactly. So if you set SQL, like you're doing an optimized table, or you're doing some kind of write to it that you don't want to replicate, you would use that instead of turning off the SQL log bit.
So are there different keywords then that we assign to that variable? Or is it just an on-off?
I think you turn it on and off.
On-off, okay.
That's what I remember.
Right, there's also
Okay.
on the slave, there's an option called replicate events marked for skip, which override that on the slave. Well, just in case you have like a backup server, for example, you might say, oh no, always replicate it. I don't care whether you're an auditing server. Always replicate it.
Interesting. Does that answer your question?
Yes.
All right, so the next version. So this is the current list of stuff. So they're going to take from. This is not out, not even alpha yet. So it's supposed to be alpha. Let me see, in a few hours. No. It's supposed to be alpha.
It'll be alpha before MySQL connected for Carline, I'm sure.
Yeah, probably. It's going to be. It's like they've started making this already, but it's not alpha yet. But it will be alpha very soon. I don't know, a few weeks maybe. But it will be alpha, so fairly highly unstable. So they're going to take the global transaction ID from MySQL 5.6, which is a very useful feature for replication, especially for environments where you have multiple hierarchies or multiple slaves. It basically allows you to just reconnect. You can just fail over to a new master without having to do any kind of logic. It's automatic, because every transaction will have an ID which follows the transaction all the way through the replication hierarchy. So it makes it really easy to change the master in the replication hierarchy and stuff like that. You don't have to worry about anything. You just say to the slave, okay, now connect to this guy as the master, and it will automatically reconfigure itself to slave. That's very cool. And then they're also taking the improved InnoDB from MySQL 5.6. So this is actually a funny anecdotal story about this. So I remember I talked about ExtraDB earlier, how it was an improved version of InnoDB. So originally it was Google who did the patch, and then there was this Japanese guy who started coding ExtraDB. His name was Yasufumi whatever his name is. Yes, he told me something. So he started coding this, and he added a lot of good features. XDB became a really good engine. But he was hired by Oracle. So he's now implementing everything he implemented for XDB, he's now implementing to InnoDB, which is very easy because it's the same code, right? So he's pretty much copy-paste, but without doing it for copyright reasons. He's actually not looking at his old code, he's still doing the same thing. So basically InnoDB in 5.6 will have all the features of XDB because the same guy is coding them. So they're going to take InnoDB from 5.6, and there's a few other nice features in InnoDB, like some online outer table options and some other things. And then they're going to add a Cassandra storage engine, so access to Cassandra through MySQL, and multi-source replication. Again, this list is very speculative. I know they're working on these, but they're not there yet, so I can't guarantee that they will be there 3 weeks from now. But I know the Cassandra storage engine already did some tests. That's fairly advanced. Multi-source replication, I haven't heard anything, so I can't guarantee it will be there. But if it is, it will be huge. Change replication in a lot of ways. But we should know more in a few weeks when it's actually released. It's going to be.
So now you know that it's speculative, not in that the features are speculative. It's speculative, and that's because you know what they're working on because you have work logs in there. Open.
Yeah.
So it's not that like, oh, we heard a rumor that maybe this is coming. It's we know they're working on it because we can see that they're working on it. So we're pretty sure they're working on it hard enough that it will be in the next release.
So this isn't like the iPhone 5.
Right, exactly, exactly. This isn't like, hey, there might be dancing girls in the next release too. We don't, maybe not. Maybe it'll do all your homework for you. We don't know.
Yeah.
No, this is like we know they're working on it.
We know what they're working on, but we don't know what will be finished enough to actually get it there. So that's kind of the...
And they probably don't know.
Well, I mean, knowing their decision model, they probably don't know yet. 3 weeks from alpha, they probably don't know yet.
Sure, you're dancing girls in a database, bro.
I know. We'll put that in the video.
You woke Lawrence up.
Sorry.
He just tweeted it.
Sherry said.
Yes, that's the TWSS stuff that Sherry said.
There we go.
And so the problem is that naming this because it's not based on MySQL 5.6 because MySQL 5.6 is not out there yet, so they can't call it MariaDB 5.6. And well, it's not really based on 5.5 either, so they don't have a good name for it or number for it. So they decided to call it MariaDB 10.0. And I personally hate it.
That's easier than having another kid.
And every time I talk to them, I ask them to change it, and they always refuse. But
The thing is, they can call it 5.6, but they plan on doing the same thing they did with 5.1, where they just add new features, but they can kind of freeze the tree because that's what 5.2 and then versus 5.3. So the problem is they can't do that with 5.6 because now Oracle's going to go back to the normal
they could do something weird, like 5.55 or 5. That would be. That's what I suggested. They call it 5.55. But they said, what if Oracle eventually releases 5.55? I was like, they're not going to do that. They're not going to do
2012.
So at the moment it's going to be 10.0, and I'm still every time I talk to them, I try to convince them. But unfortunately, Monty likes the name 10.0, and it's really hard to convince Monty. So I doubt they will change. I mean, they asked us for input, it's like, what do you think? And we all said, I mean, SkySQL, we all said it's rubbish. And they said, okay, well, Monty doesn't change his mind, so thank you for your feedback, we're going to ignore it.
Thank you for playing.
Right, but that's what's going to go in there at the moment. But if you like any of these features, play with them when it becomes alpha, or if they're still there. Right, so is this a branch or a fork? And the answer is, well, it's hard to say. It started as a real branch. So what's the difference, first of all? Well, a branch is made out of wood and a fork is metal. But so for this, what's the difference? Well,
He's trying to see this slow wait, don't you?
there's only 2 guys who actually listen to what I'm saying. So, what's the real difference? Well, a branch means that you can it's backwards compatible. I mean, it can merge back, and a fork means that you don't go back anymore. You don't look back. And I mean, it's still a branch because they keep merging back, right? 5.3 was eventually merged to 5.5. It took 8 months, but it was merged back, so it's still a branch.
And in 5.5, they merge back every month.
I mean, yeah, every time there's a new release of MySQL, they merge MariaDB to it, so there will be a new MariaDB release as well. And they plan to do the same with 5.6. I mean, obviously, the 10 is a bit weird because it's just they're going to merge back some features, but then once 5.6 is GA, the plan is to take 10, add all the 5.6 features, and merge it again. So it's supposed to be a branch still for 5.6, as it's supposed to, because you never know. One of the problems is that now many of the features that MariaDB has added, Oracle is now adding the same features to MySQL, right? So the question is, what if you take the same feature and do it worse? What do you do then with Maria? You can't really take the worst feature, right? You have to take your own. And if they change the implementation so it's similar but worse, then you're no longer compatible. At the moment, it doesn't look like any of these problems will arise. So they think that they can merge 5.6 will still be a branch. And after that, who knows?
How about version 100? I'm just worried like what's going to happen when MySQL version 10 comes out.
We're not going to run out of numbers.
Yeah.
But I mean, when it's 10 and then like...
I agree. I think they think that by the time, first of all, by the time...
Wait,
so
how old's Monty? I don't think...
By the time they get to 10, there's like, no one's going to remember that there was a 10 previously.
He's had kids. He's going to have another wife, younger wife with more kids.
You know, I agree.
He doesn't want to.
I hate 10. I said 5.55 was my proposal. Didn't like it.
Too many fives.
But it makes sense. It's based on 5.5, and it's not quite 5.6. Anyway, they didn't like it. So how do you get this? Well, MariaDB is actually available through all of repositories already. And if it's not available from your Linux provider, you can actually get them from multi-program. They have repositories as well. And you can, of course, download it from MariaDB or from our website. And support and service as well. Multi-program, they only have engineers, so the only thing they do is engineer. So you can get services from them, but only coding. If you want something else, you should come to us or someone else who does that. Training, consulting, and so forth. Of course, Oracle will not give services to MariaDB for understandable reasons. And if you want more information, you can go there. There's a good knowledge base, which is kind of their documentation. They call it a knowledge base, but it's really documentation. It's a bit weird. And it's actually a MariaDB book, and John has it. Not with him,
No,
that's what would be cool, actually. That's what would be cool to show you. But it's actually a MariaDB book, which I haven't read, but I heard it's good.
It's like the yellow MySQL book.
Yeah.
Variation of that.
Exactly. And that's it. Any questions?
Are you going to make these available? Sorry.
Go ahead.
Are you going to make these available? I say this as confidential.
Yes, it's confidential. And it was confidential in 2011, so it's no longer.
So can you make this?
Slides.
Yes.
Can you make the slides available?
Yes. I can send it to Sherry, and she can do whatever. Or something.
Thanks.
Is that good?
Yeah, so I came in late, so you may have touched on this, but what's the relationship between SkySQL and multi-program?
We hate them and they hate us.
Oh, that's
So the relationship. I mean, the relationship is that we pretty much all used to work for MySQL-DB. So when multi-program was created, it was engineers. And as you missed it, but originally their plan was to work as contractors for Sun, continue developing MySQL, but not being under Sun, right, at their own. And then, because Oracle acquired Sun, they created the branch. And a lot of service people also left, consultants, trainers, support engineers also left, and that's most of them went to Sky, and not all of them because Facebook has been poaching a lot as well. But like many went to SkySQL, so. That's like the personal relationship is that we know them well because we used to work for the same company. But beyond that, we have an agreement. So we do support, technical support for our customers, but we can't do level 3 support, which means like bug fixes because we're support engineers. So we use multi-program to do bug fixes because they are MySQL developers, so they know MySQL. But so if our customers, I mean, we have a contract with them every time we get a support customer, we pay them a percentage. And then if the support customer finds a bug or has a problem that turned out to be a bug, multi-program will fix the bug for the customer. So they work as our engineering team. Any other questions? All right, well, thank you. I'm done. If you want to reach me, you can always send me an email, and I might answer.